in this question, we've got a situation where we've got a beaker, and it's a beaker containing calcium chloride, and we've been asked to calculate the mass of calcium chloride in this particular solution, and to give our answer to 3 decimal places. In the question, we've been provided the volume, we've been provided the concentration, and we've also been provided the chemical formula for calcium chloride. So given that mass is what we've been asked to calculate, one of the first things we're going to refer to is the equation that relates mass to molar mass and moles, right? So that would be the moles equals, or I will actually add the units here, so moles is equal to the mass in grams divided by the molar mass, right? And that's in grams per mole. And if we look at the question, we've also been given, as you can see, the volume, we've got the concentration. So the other equation that's clearly relevant is the one that relates moles to concentration and volume, which is that the moles equals concentration that's in moles per dm³ multiplied by the volume, and that's in dm³, right? Now what I'm going to do is I'm effectively going to equate both sides with this equation, because the moles would be the same, right? So I mean, if you can see, the moles of this is the moles of calcium chloride, this is the moles of calcium chloride, it would be the same. So I'm going to equate these two. So that if we do that, that's going to give us that the mass in grams divided by the molar mass and in the interest of just speed, I am not going to write out the full units for the concentration and volume. I'm just going to write conc times vol. Okay, so conc times vol. Okay, but this is what we would get, right? At this stage, we have not yet made mass the subject of the equation, and we have been asked to work out the mass. So I am going to do that at this stage. So the way I'm going to do that is by multiplying both sides of the equation by molar mass, right? So if we, and I'm going to use just mR as the term for that. So mR multiplied by this side and mR multiplied by this side. Of course, we've got molar mass here already, so if we multiply mR by effectively what is 1 over molar mass, these both would cancel, giving us just 1, right? 1 times the mass is just the mass, right? So, and over here, yeah, that would just be concentration, volume, mR. But what we get ultimately from that is that the mass is equal to the concentration times the volume times the mR, right? So concentration, volume, molar mass. Do we have our molar mass at the moment? Well, we don't have the molar mass in the question, but we have what would lead us to the molar mass in the question. Is that we know it's calcium chloride, we've been given the formula of the calcium chloride, and so we can at this stage use the periodic table to work out, well, what is the actual mR. And as you know, to work out the molar mass, we need to get the relative atomic mass of each of the elements in the formula multiplied by their occurrence in the formula. So in this case, we're going to have Ca, right? So we've got a few excerpts here from the periodic table. So we've got Ca got Cl, right? And so CaCl₂, right? CaCl₂. So effectively for calcium, it's would be the 40.1, and it occurs once, so that's multiplied by 1 effectively, and then we add this to Cl, which would be 35.5 multiplied by its occurrence, which in this case CaCl₂ is 2, right? And so if you add that up, you're going to get the molar mass. And so if you do that, what you should get is just 111.1. And so this would be our MR of CaCl₂. Now at this stage we've got the MR, we still need to go ahead and work out the mass, right? So 1.11, well 111.1, but at least now we know this is 111.1. At this stage what we can do is effectively do the substitutions for our question. So our concentration is 152. Our concentration is 1.52 moles per dm³, right? So I'm going to include the units at this stage just for clarity purposes, right? So mass is going to equal the 1.52 moles per dm³. Right, multiplied by the volume, which is provided again as 0.772 multiplied by the molar mass, which, as we know, as we just worked out previously, is 111.1 grams per mole, right? And so at this stage, I would invite you to have a go, work out what that is, and if you do try and work that out, what you should come up with is approximately 130.369,184. Now, what we've been asked to do in the question is to give our answer to 3 decimal places, and at this stage we do not yet have our answer to 3 decimal places, so we do need to do that. So that's going to now be equal to 130.369, right? And we've got it to 3 decimal places, but we do not yet have our units, which we need to add, which would be, in this case, grams, right? We can also try and look at, well, is grams what we would get if we just and this is literally just for the purpose of looking at, well, how do we self-check our units, because obviously this is, I would say, a relatively straightforward calculation, but when things get a bit more complicated, tracking the units themselves can be quite useful. So in this case we're going to look quickly at this. So we've got moles per dm³ multiplied by dm³. So I'm actually going to modularize this a bit more. So moles multiplied by dm³ multiplied by grams multiplied by moles to the -1. Right. Now if we first look at the moles, you can see mole to minus 1 multiplied by moles, that cancels out to 1, right? Then we've got decimeters cubed multiplied by per decimeters cubed effectively. So dm to the minus 3 multiplied by dm to the 3. Evidently that as well cancels out to 1. And what we're left with is 1 times grams, which of course gives us grams. So even by looking at that route of just trying to check our working, we still come to the same units of grams, right? So we have a bit more confidence in our answer and the units that it is 130.369 grams. Okay.